Hi everyone. I am currently pursuing my engineering under the stream of Electronics and Communication Engineering in AP IIIT RGKT RK Valley. I have done my embedded systems internship in Emertxe Information Technology. I really thank to my mentors Anusha ma'am and Rajini ma'am who taught us all skills and subject. And also I thank you Emertxe for giving us this opportunity. So let us start our presentation. So let us go with the very basic contents that we are going to discuss in this video. So very firstly, the basics of C programming language that we have learned during this internship and microcontrollers and microprocessors. Introduction to our project. In this internship, we had done our project of microwave oven and what are the requirements and tools used in the project, implementation or demonstration, and we also done Disha workshop, and finally the conclusion. So firstly, C programming. C is a general purpose computer programming language. It was created in 1970s by Dennis Ritchie and remains very widely used and influential. It is a very popular language despite being old. The main reason for this popularity is because it is a fundamental language in the field of computer science. C is strongly associated with Unix as it was developed to write the Unix operating system. Library facilities play an important role. C has initially 32 keywords, which are reserved words used to complete our tasks efficiently and easily. And C have some data types like char, int, float, and double. Modifiers, signed, unsigned, short, long. And also qualifiers, const, volatile. Loops are for, while, do. And jump, go to, break, continue. Decision making is done by if, else, switch, case, default. And derived, struct, unions. And there are some operators that we are going to use in C programming language. They are unary operator, arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator, and ternary or conditional operator. And what are arrays? Arrays are generally used for storing the same types of data items or values that are same in the nature. Although arrays cannot be used to store the data items or values that are not same in the nature, it also considered a significant disadvantages of the arrays. Here there is a syntax of the arrays and it can be used to store the collection of primitive data types such as int, char, float, and etc. And like also derived and user defined data types such as pointers, structures, and etc. And what are pointers in C? Apart from the arrays, we talk about the pointers. They are generally used for storing the memory address of the other variables instead of storing the actual value of the variable. However, we can also use the pointer to access the whole array by using the pointer arithmetic. In addition, it also even makes the accessing array process much faster. The operators used for the pointers is, and here there are the two operators that we are used for the pointers, and the syntax for the pointers, and there is a null pointer also, and this is a syntax for the null pointer. A pointer behaves like a wild pointer when it is declared but not initialized. That is why they point to any random memory location. And functions in C. In C, we can divide a large program into the basic building blocks known as function. The function contains the set of programming statements enclosed by flower braces. A function is a block of code which only runs when it is called. We can pass data known as parameters into a function. Functions are used to perform certain actions and they are important for reusing code. Define the code once and use it many times. Here there is a syntax for the functions. And there are some of the advantages of functions in C. By using functions, we can avoid rewriting same logic or code again and again in a program. We can call C functions any number of times in a program and from any place in a program. We can track a large C program easily when it is divided into multiple functions. Reusability is the main achievement of C functions. However, function calling is always a overhead in a C program. And these are some of the advantages of functions in C programming. And there are some storage classes used in the C. C storage classes are used to describe the features of a variable or function. These features basically include the scope, visibility, and lifetime, which help us to track the existence of a particular variable during the runtime of a program. And C language uses 4 storage classes, namely auto, extern, static, and register. And preprocessors in C. The preprocessor is not a part of the compiler, but is a separate step in the compilation process. All processors command begin with a hash symbol. The following section lists down the important processors directives. And first one is hash define. Hash define is used for substitutes a preprocessor macro. And hash include undef, if def, indef, if else, else if, end if, errors, pragma. Each directives used at different point of times. And let us discuss the main topic of this internship is microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. The general microcontroller consists of the preprocessor, the memory. The memories are RAM, ROM, and EEPROM like that, and serial ports, peripherals like timers, counters, and etc. Microcontrollers are used in automatically controlled products and devices such as automobile engine control systems, implantable medical devices, remote controls, office machines, appliances, power tools, toys, and other embedded systems. Based on bit configuration, the microcontroller is further divided into 3 categories. They are 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller, and PIC, AVR, ARM, FPGA based. And here this is the image that shows about the microcontroller. And let us discuss about what is a microprocessor. A microprocessor is a computer processor where the data processing logic and control is included on a single integrated circuit or a small number of ICs. The microprocessor contains the arithmetic, logic, and control circuitry required to perform the functions of a computer's central processing unit, that is CPU. The integrated circuit is capable of interpreting and executing program instructions and performing arithmetic operations. The microprocessor is a multi-purpose clock-driven register-based digital integrated circuit that accepts binary data as input, processes it accordingly to instructions stored in its memory, and provides results as output. And microprocessors used in everything from the smallest embedded systems and handheld devices to the largest mainframes and supercomputers. And here there is an image that shows how a microprocessor is designed. And let us discuss about the introduction to embedded systems. That is, what is an embedded systems and what are the components and what are the devices or the applications that we are going to use in embedded systems. So firstly, what is an embedded system? Embedded system is a combination of both hardware and software which is intended to do a specific task. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. An embedded system has three components. First one is hardware, and the second one is application software, and the third one is real-time operating system. And there are advantages and disadvantages of the embedded systems. That is common in any system. That is, there may be some of the advantages and disadvantages. Likewise, here also, there are some advantages and disadvantages. So here the advantages are easily customizable and low power consumption, and embedded system cost is low and enhances performance. And the disadvantages of embedded systems are high development effort and also larger time to market. This is the structure of the embedded systems, which consists of a sensor, analog to digital converter, memory, and a processor, and a digital to analog converter, and an actuator. Let us discuss about the sensor. What is a sensor? Sensor converts physical sense data to electrical signals, and ADC means analog to digital converter. It converts the analog signals into the digital signals, and the processor do the process digital signal and store them in memory. And DAC, it converts the digital data into the analog data after processing. And the work of the actuator, sir, functionality of actuator is the output to input what we provide. And finally, the memory. Memory is the brain of the embedded system. There are different types of memories like ROM, RAM, hybrid memory. And there are some categories in the embedded systems. Embedded systems are mainly divided into four categories. They are standalone embedded systems, real-time embedded systems, network embedded systems, and mobile embedded systems. So basically, standalone system is also divided into two types. One is slave embedded system, and the second one is independent slave embedded system. And this slave embedded system not having the intelligent part, that is, the system follows as it is whatever we says to it. The examples of the slave embedded systems are microwave oven, and the second one is independent slave embedded system. This system can take the necessary actions. So here the example is fully automated washing machine. This is the example of the independent slave automated embedded systems. And the second one is real-time embedded systems. If our system is able to take at a given time is called the real-time embedded systems. And the best example of the real-time embedded system is the airbags. And third one is the network embedded systems. If our embedded system is connected over a network, that gives the output, that is called the network embedded system. The best examples of the network embedded systems are ATM machines, routers, Bluetooth headphones, and also home security system. And finally, the last one is mobile embedded systems. The embedded systems which are movable, all are coming under the mobile embedded systems. The examples of mobile embedded systems are cars and robots.
that is microwave oven. Introduction to the project. A microwave oven, or simply microwave, is an electronic oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. The microwaves are absorbed by water, fats, sugar, and certain other molecules whose consequent vibrations produces heat. This is the image of microwave. That is the main aim of our project. Micro oven heats food quickly and efficiently because excitation is fairly uniform in the outer 25 to 38 millimeter, that is 1.1 to 1.5 inches of a homogeneous high water content food item. Micro oven are common a kitchen appliance and are popular for reheating previously cooked foods and cooking a variety of foods. They rapidly heat foods which can easily burn or turn lumpy if cooked in conventional pans such as hot butter, fats, chocolate, or porridge. Microovens have a limited role in professional cooking because the boiling range temperatures of a microoven does not produce the flavorful chemical reactions that frying, browning, or baking at a higher temperature produces. There are various modes in microoven. The following four modes will be implemented. First mode is the micro mode, second one is the grill mode, third one is the convention mode, and fourth one is the start mode. Let us discuss about the micro mode. In this mode, food is cooked in a traditional way. It uses a maximum power of 900 watts and the maximum time that we set for cooking is 60 minutes. Next, second one is a grill mode. This mode is simply used for grilling. There is another grill heater placed in a specific location that can provide the grill effect. Now the third one is a convention mode. In this mode, the heater is turned on, the fan is provided within the microwave chamber that circulates air throughout the chamber to give that banking effect to the item placed inside. And the fourth one is the start mode. This mode is used to switch on the microwave oven, and by default the time will be 30 seconds incremented. Now let us discuss about the requirements of our project. Project requirements are tools used, that is basic knowledge in embedded C, that is our friend previously explained about that. Then second one is the MPLAB XID. This XID is used for writing our code, and XC8 compiler. By using of this compiler we are going to compile our code. And another one is the PixSimLab simulator. After compiling we have to simulate right now. That's why we are going to select the simulator, which is consisting of the PixGenius board, and the microcontroller is PIC16F877A microcontroller we are going to use in our project. And another one is the 16x4 CLCD. CLCD is nothing but character liquid crystal display, which is present in the PIC simulator. And another one is the tactile switch, and MKP means matrix keypad, and buzzer, cooling fan, timers. These are the requirements of our project. And coming to the embedded C. Embedded C is most popular programming language in software field for developing electronic gadgets. Each processor used in electronic system is associated with embedded software. Embedded C programming plays a key role in performing specific function by processor. In day-to-day life, we use many electronic devices such as mobile phone, washing machine, digital camera, etc. These are devices working is based on microcontroller that are programmed by embedded C. In embedded system, programming C code is preferred over other language due to the following reason, which is easy to understanding. C language is very easy to understanding and high reliability and portability and scalability. Next, coming to the PIC similar architecture. Here we are going to use PIC 16F877A microcontroller, which is 40 pin microcontroller. Here these are the pins. In these pins, here there are ports. Here we are going to use PIC 16F877 microcontroller, which consists of 40 pins. Here we have 5 ports, which is port A, port B, port C, port D, port E. Port acts as entry for peripheral. Port is an interface between the microcontroller and external peripherals. All ports are bidirectional and size of PIC16 F877A is equal to the size of the microcontroller data bus, which is 8 bits. Because of very less number of pins available in microcontroller for that one pin, we have many connections. Let's see that here 3 or 4 connections are present for one pin. Because of less number of pins, we are connected like that. This is the image of the PIC similar architecture, that is PIC16 F877A microcontroller. Now coming to the internal architecture of PIC16 F877A, this is the architecture diagram which consists of the port from A to E, from A0 to A7, B0 to B7, C0 to C7, like that, E0 to E7, and here ports are bidirectional. Next, coming to the CLCD. CLCD is the most common basic form of an electronic display device which is widely used. The main advantage of CLCD instead of a 7-segment display and the other multi-segment LED is that there is no limitation in displaying special and custom characters, animation and so on. There are mainly two types of displays in PIC16 F877A, that is 16 into 2 display and 16 into 4 display. Mainly we are here in our project we are going to use 16 into 4 display. And coming to the tactile switch. The tactile switch is a well recognized type of electrical switch that, like its fellow mechanical switch counterparts, completes or breaks an electrical circuit via manual actuation. While commonly found as normally open devices, tactile switches are also available in normal closed versions where current is turned off when the actuator is pressed and begins to flow once released. Next, coming to the matrix keypad. What is matrix keypad? Matrix keypads are used to provide input to wide variety of devices and appliances such as cell phones, microwave ovens and calculators. A matrix keypad consisting of push button switches that are located at the column and row interactions of a grid matrix. Here is the image of the matrix keypad which consisting of the rows and columns. Switches in the same row are connected together or switches in the same column. Here see that image, switches in the row are connected to the switches in the column. Next, coming to the buzzer and cooling form. Buzzers are electric sounding devices that generate sounds, typically powered by DC voltage. They can be categorized as piezo buzzer and magnetic buzzer. They come in different devices, designs and uses as well, and based on that they can be produced different sound. The cooling fan in a microwave attempts to dissipate the hotness created by the stove. This guarantees that it stays at a protected level. However, more seasoned microwaves did not have cooling fans, yet rather highlighted a air fan which was intended to do exactly the same thing. Next, coming to the interrupts. An interrupt is a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. Whenever an interrupt occurs, the controller completes the execution of the current instruction and start the execution of an interrupt service routine, that is ISR, or interrupt handler. ISR, interrupt service routine. ISR tells the processor or controller what to do when the interrupt occurs. The interrupt can be either hardware interrupt or software interrupts. Next, coming to the timers. What is meant by timer? A timer is a specialized type of clock which is used to measure the time intervals. A timer that counts from 0 upwards for measuring time elapsed is often called a stopwatch. It is a device that counts down from a specified time interval and used to generate a time delay. For example, an hourglass is a timer. The PIC16 F877A PIC MUC has 3 timer modules. They named as timer 0, timer 1, timer 2. The timer 0 and timer 2 are 8-bit timers and the timer 2 is a 16-bit timer. These modules help to perform various timer, counter or PWM generation. Now coming for the implementation of the project. The implementation of microwave project is done by using PICSIMLab and MPLab XIDE. The steps to follow while initializing the project. First of all, we have to go to project and we have to create a folder. In that microchip, we have to select microchip embedded, and after that we have to go for standalone project. After clicking the next, we have to select the family, which is mid-range 8-bit MCU PIX, and we have to select the microcontroller PIX16F877A. Later we have to finish the, and after that we have to select the compiler tool chains, that is XC8 compiler. After that we have go for the next process, and we have to give the name, project name as microwave oven, and we have to select the project location. After that we have to folder it and we have to finish the project. In this project we have to create main.c files in source files, create main.h files in header files. After that creation, now let us go for the project code. Here to the project, this is my code for microwave control oven. In this code, I have added or copied the files of CLCD header files and CLCD dot files from the CLCD, and I have copied the files of matrix keypad from header files and .c files from the matrix keypad. Like that, I have copied the timers and ISR files in my project. After copying that, I have created main.c file and main.h files. In main.c, I had write all the code regarding our project, that is microwave oven. After completing my project code, now I am going for the simulation. Going for the simulation is by clicking the microwave on, we have to first build the project. Successful build. Why we are going for build means, if there are any errors or bugs in our code, they are displayed. If no error found means, then build shows as build is successful. After building our project, and shows it as build successful, and then I have to load the hx file. That is, we have to go for simulation process. For that we use PixSimLab. This is the PixSimLab. Now we have to load the hx file, which is created at the time of creation folder. After loading the hx file, our code starts running like that. Now here I am loading the hx file. After loading the hx file, our micro oven gets on and shows as powering on micro oven. After powering on the micro oven with some delay, it shows the menu display screen. Here the menu is displayed on the screen. We have to select the mode which we want. Now here I am going to select the micro mode by pressing the key 1. After pressing the key 1, I will enter into the micro oven and shows the power of 900 watts. After, with some delay, I am entering into the set time display. Here this is the set time display. In set time display, we have to give time. How much time is required for cooking our food? If suppose I give like 40 minutes and 25 seconds, just like that, and by pressing the enter, that is hash key, my timer gets starts on, that is 40 minutes and 21 seconds. It starts on decrementing. Now I have to cook my food. If I want to pause my cooking, I have to press the key 5. If I am going to click the key 5, it stops or pause the cooking. If I want to again start the cooking, I have to enter the key 4. Let's see here. My cooking has been started. If I want to stop or pass, I have to press the key 5. Like that, my micro mode is going to work. After that, here my time starts past the cooking. By clicking the 4, it starts the cooking time. If I supposed to come back or stop the cooking, I have to press the sixth key. Then it again comes to the menu display screen. This is the about the micro mode. Now I am going for the grill mode. By clicking the key 2, I am entering into grill mode. That is, this is the display of the grill mode, and this is the set time. If I Here grill mode is also a same as a micro mode. Here if I give just like 10 seconds to cook my food, then after that I have to enter the fourth key, then it starts cooking. If I want more time to cook my food, then I have to press fourth key. It gives a decrement of 30 seconds. After all my cooking done, I have to wait for 30 seconds for my cooking. After my cooking has been completed, it shows as time up. We have to wait for 20 seconds more. Here time has been gets decrementing. After the food is cooked within the given time, it shows as time up and also buzzer gets on. And again come to the menu display screen. And again it comes to the menu display screen. Now we are going to use the convention mode by pressing the key 3. Here we are in the set temperature. This is the temperature display. Now I am going to give the temperature as 123 degrees and enter. It starts preheating for 80 seconds. After the preheating is completed, it again shows as a grill mode and micro mode. This is same as a grill mode and micro mode. I'm going to reset my project and it starts powering on. Up to here 3 modes are completed. Now I'm going for the start mode. This is by pressing the fourth key, I'm going for start mode. This start mode is only for 30 seconds. It will only works for 30 seconds. If I wanna get more time, then I have to enter again 4. See, here 30 seconds has been incremented. This is about the start mode. If I have to stop the time, I have to go for key 6. See, it comes to the menu display screen and the fan is off. Like this, the working of the micro oven is done. With this, we have done our project of micro oven. Thank you.